Assalamualaikum and good day everyone. In this video, I'm going to explain to you regarding current in our topic of electrostatic in medium. What is a current? Current is a moving charge and we denote this charge as a rho v, which is a volume charge. Let's assume that we have this structure of a volume charge. Okay, as you can see, this structure is a cylindrical structure. And in this cylindrical structure, it filled with full of rho v since this is a volume charge. And let's assume that this structure is in the x-axis. Okay, and to make analysis of current in this kind of structure, what we need to do is we take a sample from this structure, and I assume that my sample is in this shape. Okay, to make this box relate to the actual axis, I label this as a dx, okay, because we have structure in the x direction. So this is the dx and this one is our ds. Okay, so dx and ds means, this one is meaning, give us the meaning of small length of x, and this one give the meanings of small area. So now we already get our sample structure. So let's take a look at the mathematics. Okay, so we can write dq is equal to rho v dv. So this is the general mass representation, and you already know this from the previous chapter. And here we can make a replacement of dv by replace it with the ds dx. So we can write dq, or the small charge, is equal to rho v ds dx, where ds dx is the volume of our sample box. Okay, next. Okay, current is defined as charge passing through the area per unit time. So as you can see here, there is a word of passing. Okay, it means that our sample must move. Okay, so let's take back our structure and sample from the previous slide. Okay, so now we want to make our sample move. Okay, because we know that current is a charge passing through the area per unit time. So to make our sample move, we need to give an E field to our structure, because by having this electric field, it will introduce a force, and that force will cause our sample move. Okay, so this is the origin place of our sample. When we apply electric field to our structure, this sample will move to this place. Okay, and I label it as a blue box here. Okay, when our sample move, it will passing an area that we call it as our reference area. Okay, and this is the area where our charge is passing through when it moves from this place to this place. Okay, during the movement, we know that, or we can write down the velocity of the movement is ux. Okay, so from this situation, I can say that there are two parameters that we can consider here. The first one is charge, where it passing through our reference area. And the second one is the time taken, okay, for the charge to move from here to here. Okay. Now, the mathematical representation of the I can be write as I dq over dt. And this q can be replaced by rho v ds dx over dt. And this one can be replaced with ux. Thus, we can write it as rho v ds ux. So this is I, okay, where we have the charge, okay, where we have the charge, the area that the charge is passing through, and this is the time taken to move from this to this place. So I can write that the charge density, okay, in the x direction, because now it's moved in the x direction, is equal to the rho v u x. Okay, so because the movement is in the x direction. So now we make this equation as a general equation, because we know that the current density is a vector, so we need to write like this. It's equal to rho v u. Okay, and this current, okay, is known as the convection current, convection current density. And this is the charge that move, and this is the time taken in the of the charge to move. Okay, now you get the first model of the current. Okay, and you need to know that the convection current density denote that the charge can move in any medium. But it is, for example, it can move in water, in air. It's not specific to the conductor. Okay, because this is a convection current, and you will learn in the next topic or in the next subtopic about the conduction current. Okay, so that's all for this video. Thank you.